Hey robot makers, hope you're having a good day so far. So 2 weeks ago we started a build your own 3D printable 10-inch mini rack for the Raspberry Pi, and this is part 2. So we're going to be completing the build by designing some Pi trays, some laser cut top panels and the front cluster panel, all in Fusion 360. So let's dive straight in. My name's Kevin, Company with we build robots and projects, bring them to life with code and have a whole load of fun along the way. Okay, let me just mute that and let's get over to our slides. So yes, this is part 2 of the Fusion 360 Build Your Own Cluster project, mini rack. So previously we worked on the top section, we worked on the the top corner, the bottom corner, and the 2U pieces for each of the corners. We also covered the handles as well. So this week we're going to look at these Pi trays. I've got a couple of them here. So these slot into a laser cut panel for the front, call it the cluster panel, and these we're going to actually design 2 of these today, and we're going to design one of them, and then one operation later we will have 2 of them exactly the same, so but mirrored. So the Raspberry Pi 2, 3 and 5 can use one particular design, and the Raspberry Pi 4 they decided to flip the orientation where the Ethernet connection is, so that caused a bit of an issue. Anyways, we can get around that very, very simply. So I'm going to show you that today. So I'm going to design the Pi trays, the top panel, and also that front cluster panel as well. Okay, so here's the finished model. I've actually got it behind me just in the studio. If I go here, you can probably just about see it there. It's got one of the pieces missing there because I pulled it out literally so that I could show you one of them. This was previously just sat in there. I've also got a laser cut panel which hasn't been fully finished. I've not popped out the middle section, and I've not also popped out all these little dots, so we can do that. Just push them out and away we go. So these are all 6U holes for the clustered pieces to sit in. So when we're finished we'll be able to get one of these, put the Raspberry Pi in it. So it just requires a couple of M.25 screws, and these are some 6 M6 screws and the little square bolts for fastening this into place. I'm just going to do this to show you the kind of finished result, and I'll also show you how we can turn this Fusion 360 design. It smells of burnt wood as well, this, just being freshly lasered about an hour ago. And you get the idea that if I start putting all these pieces together, we then have a nice finished cluster piece. So that goes into the middle there, and we can screw that piece in place there as well. I'll just do that. I'll end up with a big black mark on my chin from doing this, no doubt. There we go. So we can now just screw that in place. A screwdriver here just to make it nice and secure, and that's all it takes. So this will just screw into place. Just get rid of those last bits of there we go. Last bits that just needed finishing off. These ones are a little bit messy. There we go. I've got little circles all over the place. Let's get rid of those. So you can see we can actually have up to 7 Raspberry Pis, all the different types of Raspberry Pi, all the way from the very first to the very last, or the very current model. We can even make a different version, I've not looked at this yet, for the Raspberry Pi 2W. So I've got one of them, visited the Cambridge Cam Jam Festival yesterday, and we've got the Raspberry Pi 2W there. And it's new kind of packaging, which is really neat, really, really small packaging. So we could even do a whole bunch of racks for a bunch of those as well. So you get the idea there. We can just put in the next one and, you know, build out our cluster like so. So we just need to provide power to each of these, and we can do that through some additional modules that we'll look at in a future episode. So that's the finished one that I've got behind me there. I've also added to this a Pimroni Plasma Stick 2350. So the Plasma Stick is a little board. We've got the little package there. So it's a little board that can do LED strips. It makes talking to LED strips really, really simple. I've got some of the non-Wi-Fi versions here as well, so I can just show what they look like. So this is the Plasma 2350, and they do a Wi-Fi version as well. And it's a smart LED strip driver. So you can simply just plug in the LED strips into that connector there, and it can drive this through MicroPython. So very, very simple. So what I've done with this one is I've set up some code so that you can send it an MQTT message and it will change the color. You can even send it a hex value for the colors that you want it to display. We can get it to flash, we can get it to glow and all kinds of things like that. So the idea is, again, just look behind me there, you can just see that red LED strip. That means that we can put some software on our Raspberry Pi cluster and say one of the nodes is not working correctly. We can indicate which node that is, or can just make it go red to say that there's a general problem, something like that. So it's just kind of an indicator that we can put into our plasma into our 3D printable 10-inch rack cluster to give it some extra jazziness. So what we're going to be looking at today then is the Pi tray. We're going to look at the Raspberry Pi 5, 4 and all the other models. They can all fit into this very similar module here. I'm also going to use the Robot Maker's Almanac to help me find all the different dimensions that we need for this particular project. So there we go, I've got on page 27 there, we have some dimensions. You can probably just about see it there, for all the different holes, mounting holes and things like that. So I'm going to have that to hand just to grab some of those. If you want to get yourself one of these Robot Maker Almanacs, they are available on the kesrobots.com website as well. The cluster panel, we're going to design this one very shortly. You've just seen me hold that one up. So this is the panel that's going to allow us to attach all our Raspberry Pis to the front of this, and we can have on the particular build I've done, we can have 2 rows of these. So this can be a second row to my cluster panel that I've got there, to my mini rack that I've got behind me there. We can even, if we want to redesign this, so instead of having 7 all tightly packed in there, we could have, say, 5 Raspberry Pis or 6, depending if they've got the NVMe base or some kind of hat that means that it takes up a bit more space. So we can make this work however we like, but I managed to squeeze in 7 Raspberry Pis quite comfortably, as you can see just behind me there. They're all nicely snug in there. Okay, so if you like what I do and want to make more of these types of videos, please give this video a like. If you haven't already subscribed, please consider subscribing. It means so much to me. It costs you absolutely nothing to do that as well. It's just a little click of that subscribe button at the bottom there. And if you want to drop me a comment on Raspberry Pis, let me know what your current Raspberry Pi project is. I'd be very interested to hear more about that. I do go live every single Sunday at 7 o'clock GMT, so you can hang out after the main part of the show, and we can have a question and answer and a bit of a general hangout. Okay, I think it's time to get into Fusion 360 and start designing these pieces. So before I start this, I also just want to show you where you can follow along with this. If you go to kesrobots.com/learn and you look on the most recent courses, you will find that we have the mini rack course available for you. In fact, I can just click on this free courses, click on the mini rack, and it'll load up that one and we can follow along. So I'm literally going to have that on a screen next to me over here, so I can find what operation I need to do next and carry on with that. Of course, this now decides to go slow just because I'm streaming. So anyway, let's get over, there we go. So there's the course. We can see all the different components down the left hand side there. So we're going to carry on where we left off, which is the cluster panel. So that's what we're going to look at next. We're going to look at the cluster panel. So let's go over to Fusion 360 and let's create a new file. So let me go to this screen. This is a little bit better set up, and it also won't keep popping in and out, which it sometimes does, which is a little bit irritating. So let me just organize my screen here. Let me just grab that. I'm going to save this as the live cluster panel. Okay, so the first thing we need to do is create a new sketch. So let's grab our create sketch tool. We're going to create it on this front panel here, this front origin point here. And what we need to do is we need to name this sketch. It's best to name them as you go. I'm just going to call this one, so let's rename this to cluster panel. Okay, so this is essentially a rectangular shape. We can either use the rectangle like this and then try and position it around the origin. It really doesn't matter too much. We're going to join this to our design later on as a separate component, but I always like to sort of start out. So if I just grab that and press R for rectangle, you can see on the right hand side here in this sketch panel we've got this center rectangle. So if I click on that, click on the origin point and then drag out, we can get something that works more like what we want, because it's now locked into place at that center point. So I'm going to do D for dimension. I'm going to grab this very right edge here, and I'm going to type in the first dimension. This is 2u, and when we looked last week, a single u I think was 44.5. I think that's what I went for. Some people might argue it's 44.45, but for this particular design I think 44.5 will serve us well. It's actually got 2u, so let's draw a line from the middle to the middle. That'll help us in a minute or two, and we can just check to see if that center point to the top is 15.875. Let's do that. What have I done wrong there? So that's the pitch between the two of them, so that's fine, that makes sense. So I'm just going to delete that dimension there, that's fine. I'm also going to make that one a construction line. You can see there it changes to a construction. We can either press that little construction thing, or we can press X on the keyboard and that will toggle whether it's a construction line or not. And again, if you're wondering what the difference is between a construction line, if I take it off so it's not a construction line, so it's now just a regular line, when I move my mouse over these different top and bottom halves, you can see that they turn blue. Blue means that that's a solid profile, and when we look to do an extrude or to create new geometry or cut away geometry, that will do it one section at a time. So really what you want to go for, if you can, is a single profile for the whole piece rather than splitting it in two, because you're having to click and select all the different parts of that geometry later on. So it works best if we do this. Okay, so the next one we need to do, let's do a line here. This is going to be 222.25. It's quite long, and let me just see. So that actually, instead of being 44.5, should be 89. It's 2u. A single u is 44.5. So 44.5 times 2 is 89. That looks more correct. Now that's the middle part. What we need to do is add some bits to the edges now, where the screws are going to go into the rack itself. So let's just do a little line. Now there's a couple of ways that you can do this when you're putting a sketch together. You can try and be really precise. So I know that this needs to be 15.875, which is the pitch of our screw holes. So we could do pitch equals 15.875. That will actually create in our little our parameters box a little parameter that's called pitch. So we can reuse that dimension over and over and over, and we will do in this particular design, so it makes sense to do that. You can also click on that plus button to do a new dimension as well. It's the same difference, but you can just type it when you're typing in a dimension. So we can either do it this way, where we type in each one, and that would also be like the pitch, and then we can join those two lines together like so. Another way that I like to do, we need to do the same on the other side, is just make it some arbitrary angle that's not like 45 degrees. It's just some random angle. I make them so that they're not actually straight, and then I will lock using the horizontal and vertical constraint tool. I'll lock them all in place, and that way I guarantee that they are now horizontal and vertical, and I can simply just come up here to that top one, type in P for pitch, and now that's correct. And I did that with just one dimension and two constraints. On that side I had to do 2 dimensions, one for each side. And I didn't know whether this line was truly vertical, but by the fact that these are both the same dimension, it should be. That's the idea. Okay, so that gives us those. What we need to do next as well is also make that a construction line so that it's not messing up with our geometry. And we also need to put, so Robert's just asking on there, where are the STL files available? So if you want to grab the STL files for this particular project, if you go to the projects and mini rack, you will find all the STL files are actually on here. So I think if I scroll all the way down, you'll find there's all the STL files, and there's actually like an STL viewer. You can download the individual files from there, but they're the actual STL files that you're looking for there, Robert. Okay, let's go back to Fusion. So what I need to do now is create some holes for this to connect to our cluster panel. So they're in groups of 3, and they are all a M6 hole. So if I do M6 equals 6mm, and I now make all these holes M6. If I just press M, it'll jump to that first one because there's no other parameters that start with M. Let's do that again. and M. I need these all to be the pitch distance apart, so if I do that and do pitch, so I'm doing D for dimension, I'm clicking these center parts, and I'm doing P for pitch. Now let's do the same with these, so they're pitch distance apart. Now you can see that they're all kind of wibbly wobbly, they're not aligned yet, so we need to line these up. So what I'm going to do for now is I'm just going to pull these out to the side for a second, because what we really need to do is add some extra geometry in here. I'm going to click, let's move this over and zoom in a little bit. I'm going to click that center point there. You can see it turns to a square, and it's connecting to existing geometry, which is the center point of that line, the midpoint. And then I'm going to move this over, and I'm going to make that to that midpoint as well. So we've got a nice solid line there. Let's make that one a construction line. Now because I've created that there, it means I can now create a new line from the very midpoint of that line to the very top. And we can do the same to the very bottom of this one. This will just help it when we come to lock those circles in place. I'm just going to click that line there, do that construction, click that line X for construction. And now if we create some geometry between these, I'm just going to do a line between these from the center to the center, like so, and then we can use that horizontal and vertical constraint to make these all line up nicely, like so. We also want these lines to be construction, so click on them, press X. Now that middle one should lock nicely into the midpoint of this line here, so let's drag that middle one over, and you'll find that it'll lock to the midpoint. There we go, the little triangles appeared, and that's now locked into place. Looks like that line there. Let's see if we can find that one is also not construction line. So there we go, it's now construction. Let's do the same with the bottom ones. Find the middle point with the line tool. I'm pressing L for line, which is the shortcut for the line tool. Click on that. Let's click on that midpoint to that middle point there. So when I press L, essentially it's just using the line tool there. Right, we can probably make these construction at this point. It's a bit easier to find it before they overlap the other line. And then let's use that horizontal and vertical constraint to make these all nice and lined up. They're all separated by that measurement that we put in before, that pitch. So if I grab this middle one and drag that over to the middle of that line there, you can see that little triangle appears. That means we've found the midpoint, and now that's everything that we need it to be. We just need to repeat the same thing on the other side. So let's do that middle line, put that in place, press X for construction, L again from that midpoint to that top midpoint. Let's select it. So you can actually press spacebar to get rid of any selections. Let's press L again and make that go to the midpoint of that bottom line. Press X for construction, and then let's just quickly do 6 little circles. Oops, doesn't matter if they're massive, we can make them. D for dimension, and then let's do M, which is the hole size, M for the hole size, D for dimension, click on the edge, M for the hole size, and just repeat this all the way up with these ones. Okay, we'll do L for line. Let's find the midpoint of each of these circles, and do the same with that again. I'm just going to make them construction lines, and we need to also make them horizontally locked into place. We now need to either click on the line itself like this and just be P for pitch. Probably the easiest way to do this, P for pitch. So again, do the line to the midpoints. I can do that to that point there. Click on the line to make them construction lines. You can select multiple lines at once. You see when I double clicked, it actually found all the connected lines, and that's called chaining. That's a kind of helpful thing. Let's go for the horizontal and vertical constraints. We need to do D for dimension to make that top one there 6mm, and then we need to do D for dimension, find that middle line, and then do P for pitch, and then just press P for pitch. It'll just find those dimensions. So now we can grab that into the middle point there. It turns black, that means it's locked into place. There we go, and there we go. We've finished the first part of the panel. So if I just press finish sketch, so now you can see now when I hover over that, it's all one piece of geometry. Because we didn't do a construction line around the circles, they now are kind of cut out of the profile, and that's exactly what we want to happen. Now I'm using basswood, so this wood that I've been laser cutting, I think it's 2 or 3 millimeters. I think 2 millimeters is probably what it actually is. So this is actually fine. It doesn't flex too much. I was worried that it might sort of bend in or out too much under the weight of all the Raspberry Pis, but that actually doesn't happen, so it's fine. So if we now do E for extrude, we can select that profile, and we can just extrude it back by 2 millimeters. If we wanted to do this and really have it strong, we could cut out 2 pieces and overlay them. So let's actually just pretend that we've overlaid this. If I go back to that by just double clicking it, we can say in fact this is going to be 4, because it'll be 2 pieces glued together for extra strength. Now the other thing I like to do is I actually like to model the colour that this is going to be. So if I press A, that'll bring up the appearance panel, and I've found a nice pine. If I type in pine in the library, you can see I've actually favorited it there. So if I drag that onto the actual piece, we now have that nice pine colour. Now sometimes there are different materials that haven't been downloaded, so you can't just drag them. You have to click on the little download button first. It'll then download that. It's usually quite quick to download, and then you can drag that across. So if you don't see that, you just drag it across after you've downloaded it. So I'm going to go with my nice pine for my favourites. To add it to your favourites, if I scroll to the top there, in fact if I cancel the library, you can see you've got favourites. So that pine is one of my favourites there. So to add it to a favourite, just right click on the thing there and just say add to your favourites, and it'll do exactly that. So you can then just drag that pine piece to your model. Once you've done that, you can if you want to specify individual faces for materials. It can get quite complicated if you do that, particularly if you've got lots of geometry, because you will have to go into each face of your model. So if I did this on here, I'd have to go to the inside of each of those holes and apply that material, and then do the same on the back of and on the top and on the sides as well. So just having it done to the bodies and components is probably the best option. So I'm just going to click on the close, just bring that up, click on close for now. That's good. I'm going to click save before we do anything else. Hit enter for that, and let's go to the next piece. So that gets us the outside. We need to have the holes at the top and the bottom, and we also have to have some nice rounded corners, and the other thing we need in the middle is a hole for these for the Raspberry Pis to sort of go inside. So what we need to do is create this hole, and we need to create these circles at the very top and bottom. So let's do that as a new sketch. It's easier to do this as a new sketch because it just looks cleaner. So let's click on that. Let's call this one, let's rename this one to be holes, just so we can find that later on in our browser tree. And what we need to do now then is I'm going to press P for project, just to get that existing geometry into this new sketch. Just makes it easier when we're trying to draw lines and so on. So what I want to do now is I want another rectangle. I'm just going to freehand it, half a rectangle like so. If you find that you can't see your lines very well because the material of the body is kind of poking through, you can literally just click on the eyeball, and then you've just got your sketch geometry showing through. So I find it a bit easier sometimes to work with this. So what we need to do now, because we've got, I'm going to enable that other sketch there so that we can actually drag this to, if that doesn't show through, we can do P for project. We can include those lines that we created on the previous one, and then we can just grab that so that it attaches to it, both sides, like so. And what do we want that to be, top and bottom? I think that is right. So the actual hole needs to be, let's do D for dimensions, and this is going to be 56 inside. Now it's 56, but it's not centered, so that can actually sort of slide around. So what we need to do is lock that to that center point, and the easy way to do this is to do from that top line, click on the center piece, click on there, and then for the measurement it's basically half of that measurement there. So if I click on that, which is dimension number 29, divide that by 2, it then lock that into place, and it's now precisely in the middle of our design. So the next thing we want to do is we want some circles at the top here. We want a whole bunch of them. I think there is 7 that we want to have on here, one for each of the Raspberry Pis. And you can do this a number of different ways to figure out how wide does each of these need to be to fit perfectly between these pieces. So one of the ways is, if we come down here, we can create a little line like so, and we can give this a dimension, and this dimension can be, in fact, before we do that, let's figure out what the dimension of this top piece here is. It's going to be driven because we've not we can't set that, it's already been set by the previous sketch, 222.25. So if we now say that dimension there, which is D32, divided by 7, we get 31.75. So that 31.75 is now a new dimension. So that dimension we can use to figure out the pitch between each of these. So if we do D for dimension between each of these, we can now just click on that dimension there, D31, and if we do that all the way across, we'll end up with really equidistant holes. The holes also need to be nicely centered, so let me just find where I did that. So if we just create a new line, create a line between there and there, and then find the center point and just move that out to the end there, make that one construction and also that one a construction by pressing X, and then we just need to find the edge of that circle. It'll be a bit fiddly to do this, so zooming in might help. Sometimes it does do this, and you can just delete that. So let's just find the edge, and that's going to be the M6. So let's just do that, M6, M6, D for dimension, M, and then 6, which is the parameter that we created before. Find the edge, M6, find the edge, M, and then 6. Okay, so we can now make sure that they're now locked to that center line. You can either do it just by clicking on it and doing the coincident constraint. That's probably one of the easy ways to do this. Do that with all of them. And then we can put the pitch, that 31.75 for all of them. Okay. So if I now go up here, I do middle point to middle point. And was it D32? Nope, it wasn't D32. What was the dimension? D31. So if I go back there, D31. We've now got the correct distance between those holes. D31, dimension, D31. Does get quite repetitive this on this particular model. D31, middle point to middle point, D31. And then there we go. So that's now all equidistant between each of the points. We need to mirror that so that just noticed that they're blue, and that's because we've not defined where the center point is. So what we could do, we could either do a line between here and here, which is half of that D31, or we could just do a line up from here to that middle one, make it a construction line, and use the horizontal vertical constraint. They've all turned black now, and they're now all perfectly aligned. Now we could mirror these. We've created all that geometry, and rather than going through and doing all those steps again, we could make our lives a lot easier. We go down to the create and mirror tool. You can do this within a sketch or outside of a sketch. So the objects, we want these holding down the command key on the Mac. It's the Alt key on the on Windows, and then the mirror line is actually just going to be this mirror line here, and you can see what it's going to look like. If I click OK, there we go, we've got all the same things replicated onto the bottom as well. So we're going to finish that sketch, and we need to extrude. So let's bring that body back so we can actually see it. I'm going to enable just the holes that we've just created there. I'm going to press E for extrude. I'm going to click on the individual holes. And I'm also just going to drag these back so that it cuts through the existing geometry. Now, remember what I was saying before about if you don't make it a construction line, you have to start picking the individual pieces like this. That's why it's of benefit to just have the profile as a single profile by using the construction lines. But for this one, we can just quickly go through and select these holes. Okay, so for the distance we can also set that to just all, and it'll just limit it to the depth of the body that we've created there. So click OK. Very nearly done. So next we just want to smooth these corners out, because these are quite hard at the moment. And you might have noticed on my model we have these nice rounded corners. If I can sort of zoom in there, you've got this nice rounded corner there. So we can do that with the fillet tool. So the fillet tool is this one here. It creates nice rounded geometry. We can just move that over here. So that edge just there, we want to make that 4mm round, and we can use the command key held down to select all the other pieces, and we can do this in a single operation then rather than to do it 4 times. So let's just zoom in a little bit. That edge there, and then if I hold down Control, you'll see that we can actually see through the geometry, so that we've got that bottom corner added in as well. So there we go, we've got 4 edges, 4mm, boom, done. So that is now almost the finished piece. So what we want to be able to do is bring this into a piece of software like Lightburn, so that we can laser cut this out with a laser cutter. You could 3D print this as well if you wish. I've not gone for that. I went for a laser cut because laser cutting, I think it takes like a minute for it to do this. It's very, very quick, maybe 5 minutes at the most. So the way that we can create a sketch for a DXF, which is the format that laser cutters use to bring in, we can create a new sketch to do this. So we click on New Sketch, click on that face there, we do P for project, just click anywhere within that that single face, click on Finish. I'm going to rename this one, let's rename it to DXF Export, and if we now right click on that sketch, there is actually an Export DXF file format, so we can click on that. We can call this one Cluster Panel DXF. It's going to save it to my Downloads folder. We can click Save, and if I were to load up something like Lightburn, let me just load this one up. So Lightburn is the software that I bought for my laser cutter. I've got a Creality laser cutter. Click on the Import, and then we can click on the Downloads folder, bring in that cluster DXF. I'm going to do Edit, Delete Duplicates, because sometimes you get little duplicates happening. There's none on this one. The next thing I like to do is group everything together. So right click, Group, and I'm going to rotate this one round. So I'm going to click on that little edge there. Oops, nope, we don't want to scale it. Definitely don't want to scale it. So let me just struggling here to get that to turn. What I'm going to do, I'm going to click on Arrange and Group. So we've got it grouped, that's good. We want to rotate it round. Let's see if we can do that from here. Rotate counterclockwise, perfect. If I now drag this, it's actually not letting me select this very easily, which is not great. Let's click on the numbers at the bottom here. So these are the different layers that we can create, and for my laser cutter, if I just double click into there, the speed is 5 and the power is 100. I've got quite a low powered one. If we just deselect everything, maybe that will help. So deselect, select all, there we go. We can just click on that and drag that down like so, and I can now send that to my laser cutter. I usually do like the frame operation, which makes the laser cutter head, without having any power on, go around the outside of that, and I would have a nice piece of 300 by 300 basswood. That's what I use. You can see on here it's less than 300. That's 280 and that's 300. At 320, 300 would be somewhere there, so that will fit very nicely within that. And that's all that I need to do then. I would just hit Start on my laser cutter. I just hide my face for a second. Start, which is just over here. That would start my laser cutter going, and it would then cut that piece out for me. So that's how we can do that in Lightburn from a Fusion 360 design. So that's the first one done. Let's do a new sketch, and let's do the pie tray. So the pie tray is going to hold our Raspberry Pi in place. Let me just bring that up on my other screen. And we just grab that pie tray that we didn't put in. So you can see on here we've got this nice hexagonal design on the back. That's to let some air through so it can cool down a little bit. We have some mounting points at the corners for the Raspberry Pi to sit onto. So you can see on this one I've only done like the 2 diagonal ones, and these are just M2.5 screws. You can't put an M3 screw through, and an M2 will be too loose, so M2.5 is what the actual holes are on a Raspberry Pi. And then we have these cutouts for the Ethernet and the USB connectors, and there's a hole for each of them so that they can be mounted to the cluster panel that we created just a moment ago. So let's make a start on this one. I've created a new file. Let's create a new sketch. That's going to be on this bottom surface, and we're going to call this one tray base. Let's just open that out, rename our sketch to be tray base, like so. I'm going to save that before we start. So this is live Pi tray. And let's create some geometry. So I'm going to refer to my Robot Maker's Almanac, page 27, where I've got the Raspberry Pi 5. I'm going to click on the rectangular tool, and I'm going to do the center rectangle, which is that one there. Let's drag that out like so. So what I'm going to do first of all is just do a large rectangle. Let's do D for dimension. This needs to be about 85. And it needs to be 56 tall, like so. Okay, now the Raspberry Pi, if I just do 4, no, in fact let's not do the circles just yet, let's do a rectangle. The Raspberry Pi has a number of mounting holes for the screws, and these are slightly offset, they're not completely to the middle. So it helps to have the reference dimensions, which is what the Robot Maker's Almanac is there for me. So if I click over here, drag this out, this is 49 millimeters, and then the top height is 58 of the width. And I'm going to double click on that to select the entire rectangle, press X to make all that to be geometry, construction geometry, and then on the corners I'm just going to find that where it turns into a little square. And I've done a C for circle, so I can just drag that out. Make sure I'm getting the right geometry there. And then we need to do a new hole dimension, so I'm going to call this one hole equals 2.5. These are 2.5 millimeters, so I'm going to just find that edge, do H for hole, do that on that one there, H for hole, D for dimension, oops, hole, D for dimension on that edge just there. I keep doing the wrong one there. Okay, that's done. Click away. D for dimension on that one. H for hole. There we go. So currently this is kind of floating about within there. So we need to sort of lock this in place. So I'm pretty sure this is 3 millimeters from the edge there to there. So if I do 3. And we want this to be centered within this. So the little trick we did before, we just find the point where it's centered there. We've got the little triangle next to the cursor. Click and then click to the origin point. Click to make that a construction line with X, and then use the horizontal vertical constraint to lock that in place. I'm pretty sure they're about 3 millimeters. We can just check and see. Yep, 3.5. Interesting. Okay. So I'm just going to check on there. That looks right. I just want to check if that is 3 millimeters or whether that's 3.5, because I've actually not got that on my notes. So let me just open up my previous one, mini rack and Pi tray. Let me just check and see what that actually is on that very first sketch. So I've got 3 millimeters on there, so that's fine. Okay, just want to make sure I'm giving you the right dimension. Okay, so that's good. We can now round the corners. So let's close that data panel. Let's click on this fillet, and we can click on that top edge and that right edge, and we want that to be 3. Let's click 3 there. The same with the right and the bottom. That's also 3. And we don't want anything to be on this edge over here, because that's going to be where the front face is going to be. So we just want those two there. And then what we also want on the edge here, let's just use the L panel. I'm just going to do that thing where I do a random kind of angle for each of these. Oops, that needs to lock to that corner there. And then I'm going to use the horizontal and vertical constraint to make these all nice and straight, like so. And if we just do D for dimension on that top one, make that 3mm, that's going to be the thickness of if we look at this sort of side on, this piece here is going to be 3mm thick. Okay, that's good. And that's also not going to be construction geometry, because we want to be able to pull that out 3mm thick, so we're going to leave that as a solid line there. Okay, so let's click finish the sketch. We now want to extrude this up by 3mm. That seems to be a nice depth to make this quite solid. So 3mm up, like so. I think I'm going to make this a nice orange colour as well. So A for appearance, drag my orange colour onto there. I'm using the Prusa filament, Prusament orange for this particular one. So we need to create a new sketch on the top there. And let's call this one holes. So what this is for, the Raspberry Pi needs to be lifted off the board ever so slightly. If I hold this up there, can you see how there's these little standoffs? So they're 3mm high, and that's just enough clearance for all this sort of solder header, all the solder pieces that stick down through the board. So we just need to raise it up that little bit. So that's what this next step is about. So if we do C for circle, find the midpoint of that circle there. You should see it like it turns blue, but if you don't, you can just create it to the side. Let's do that. Let's do D for dimension. Let's click M3 equals 3. It's going to be an M3 hole, or is it, no, let's do 5 actually. Let's do 5mm. And we can use the concentric constraints. If we find the edge there, find our circle, they're now going to be concentric with each other. So if you can't quite find it because it's too small, you can do it that way. So you could just create a bunch of circles and then use that concentric constraint for each of them. So each of them needs to be just 5mm. I'm just going to type 5 for speed on here. Let's do that one there, that's 5. And then we can just use that concentric constraint. Just find the edge, boom, there's that. Find the edge of that one, and then the edge of this one down here, and finally that one and that edge there. Okay, that's all we need for that particular sketch. We can then click on finish. We can then do E for extrude, and we just want the new piece that we've created, and it's going to be 3mm up. Let's do that one there, and then that final one there. Click OK. So you can see now the Raspberry Pi can just sit on there, and because we've used the proper dimensions from the Robot Maker's Almanac, we know that this is going to be a really nice fit for the Raspberry Pi. So the next thing we need to do is we need to switch that tray base sketch back on, flip this round using the little cube at the top right there, and we want to do E for extrude on this end bit here. So this needs to be 25.98. Seems a bit of a random dimension, but that's the one we're going for. And we want to create a new sketch on the face of here, so we can switch off that sketch there. So this is going to be where the holes are for the Raspberry Pi. So let's create new sketch, click on that new face that we've created, and let's call this one mounting holes. So rename mounting holes. Okay. So what I'm going to do, I'm going to create a new rectangle on here. But that rectangle needs to be 89. And it needs to be, let me find that. It needs to be the same height as the existing one. So we can use the coincident constraint and just click on a corner or something like that. Now we also want this one to be locked into place. So again, we can find an edge, find that center point. Oops, find an edge, the center point, and drag it down. Sorry, it's not finding what I need there. So D for dimension, there's the center point, there's the edge we're looking for, and that needs to be the 89 divided by 2. That's now the correct thing that we're looking for. We need a bunch of holes. We need one there and one there. These need to be M6, so let's just do the, I think M6 doesn't exist, so M6 equals 6. We can use that over here now. And then select the M6 hole, and these need to be locked in place along the center line. So let's find that with finding the edge, finding that little triangle for the midpoint, extending that out all the way. If we are careful, we can make this so that it's completely horizontal. You can see on the bottom of the cursor there, you've got that little square to say that this is at 90 degrees, and we can also make that one construction line as well. So we need to lock that into place there. Lock that into place there. And these are 73 millimeters apart. So let's find the middle point of each of those, and then drag that up. So that needs to be 76. And they're still blue because they can still move around like that. So you know what we're going to do here. We can find the midpoint and one of the edges, drag that up as a dimension. I'm really having a problem with this. There's the center point. There is the midpoint that we're looking for. And then we can just click on that 76 divided by 2. And now that's locked into place. Now I'm going to type in some dimensions, and these are going to seem really arbitrary, and I'll show you how I found these out after I've created them. So what I'm going to do first of all is just do 3 rectangles. So that's the Ethernet connector, this is going to be the USB, and then the other bank of USB. And let's create this from the bottom of our thing. It's going to be 8 millimeters for this one here. We're going to use the collinear constraint for the other USB because these are essentially the exact same height, so that's going to be in line with that. But the Ethernet is ever so slightly further down, so that is from the bottom, that's going to be 7.3. The Ethernet connector is going to be 17.45 wide, and there is going to be a 2.5 gap between that and the USB, so 2.5 between those two, and there's actually a distance of 3 millimeters between those two. So let's just zoom in a little bit there. Between that edge and that edge, that's going to be 3. The width of the USB is going to be 15.5 for that one, and then for this one it's going to be 15.71. Again, it seems a bit arbitrary. And now if we grab this, we can move all of them along, and I think there is a 0.75 gap just there, so 0.75. That looks correct. So we now need to do the height of each of these, so from there to there. The Ethernet is 14.65. This one is going to be 15.98. And this one is also going to be 15.98, like so. They are the correct parameters for the holes. So now that we've done that, we need to extrude our geometry. We could actually add the fillets in. Let's go back and re-edit that sketch and just add some nice fillets to the corners. The corners need to be 4 millimeters, so let's just find that. 4. That one there is 4, this one is 4, and this one is 4. We also just need to make sure these are horizontal as well. Why is that complaining? That's because this line needs to be horizontal and vertical, and it also needs to be the midpoint as well. I think you just lost that because when you do the corners it kind of loses some geometry sometimes. Okay, go back to our workspace. I'm going to do E for extrude. We're going to grab that and grab this. We're going to spin round so that we can actually see the back side there. We're going to click on that, and that's going to join that new geometry to our existing model, because we've got the join operation just behind my head there. So I'm going to click on OK. And now we need to push out, let's switch back on that hole, mountain hole sketch. We need to push out those 3 holes. If I just grab those, we can then grab the arrow, push it back. I always like to set the distance to be all. So if I click on that there, it's just going to cut the geometry just what it needs to be to push that hole out there. We can switch that sketch off now. So there we go. So how did I find these dimensions for each of these three? And I printed them out several times, and I can guarantee they're a really perfect fit. So the way that I found this out is I loaded up the Raspberry Pi model. So on the Raspberry Pi website, you can actually download a step file. So if I go for Raspberry Pi, I've already preloaded this one into Fusion 360. So I'll just take it a second for it to find that. Shouldn't take it that long, come on. So wait, there we go. So if I find Raspberry Pi 5 step, we click on that, and let's find the one that you can actually, there you go, that one looks correct. Let's insert into current design. It looks all kind of weird and grayscale, but that's fine. I'm just going to move this up for now. And the other thing that we need to do, so that when we move this, everything stays locked together while it's still selected, if we go to assemble and do rigid group, it will lock all the components of that Raspberry Pi together. So we can just click on that, click OK, and now if we grab this, it will actually move everything together. We also want to, you can see there's like a little anchor, very small anchor on top of there. We want that to actually not be anchored, so unground from parent, so that we can now actually move this around. And you can see there we've got these little holes. We can use this to test out our mounting holes. So that hole there is that hole there. So if I do the joint, click on that little hole just there, find that mounting hole like so. Sometimes it flips it over, so you just have to use the flip command. If I just move my head out of the way, there's a little flip command there, and then sometimes you also need to rotate it round just by clicking on that blue circle. Rotate it round like so until we get to 0 degrees. Click OK, and now if we look over here, let's just make that home, spin it round like so. You can see that it's a really nice fit. So the way that I actually found these holes is I started out without actually having those holes in there. So if I just hide that, if I suppress that feature for a second, you can see there that we've got no holes at all, and we can actually create a hole. And once we've created a hole, let's just unsuppress that. We can actually start playing about with this. So we can click on that edge there. We can do push and pull. So if I do P for, sorry, not push and pull on there, I'll finish that sketch. If I click on the edge there, if I do Q, I can extrude or pull geometry. So I did this a little bit at a time to find a really nice fit for each of those. Once I'd finished that, I then took a snapshot of what the dimensions were for each of those holes. So that's how I figured out that these are a really nice fit. I mean, you can see there that that very end one could probably come in a little bit more and it'd be fine. I think that was the 15.71 versus the 15.5, which is what the middle one is there. But that's like a really tight fit. You can see there's probably a little bit more wiggle room for each of these, but there, as a general rule, they fit really nicely. So we can switch off that Raspberry Pi now. We can switch off the joint, that little thing that appears. And there is our Raspberry Pi 5 Pi tray. So what about the Raspberry Pi 4? So if I show you the difference between a Raspberry Pi 2, 3 and 5. So that's the Raspberry Pi, just trying to find which is the 4. This is the 4. So this is a Raspberry Pi 1, I think it is. See on there, Raspberry Pi model 1.2. You can see that the Ethernet connector is at the bottom as I hold it like this. So if I get the same one facing in the same orientation, try and get these right, and I show you these, you can see that the Ethernet connector on the Raspberry Pi 5 is actually at the top rather than at the bottom. So we would have to go through and flip those dimensions. But I thought we could just flip the entire body and we would therefore end up with a second Pi. So if I just open up on my little tree over here, rename that body to be Raspberry Pi 5. Now let's do another operation. Let's spin this back round, let's say that way. We're going to create a construction plane. So click on that construction offset plane there. Just click on that face, and I think I did 20 millimeters just to give it a bit of distance out. That's going to become our mirror plane. We can use that to mirror a body. So if we now go to create mirror, type is body, the mirror plane is going to be this plane here. Click OK, and we've now got a Raspberry Pi 1, 2, 3 and 5. 1, 2, 3 and 5, and that's the Raspberry Pi 4, and that's Raspberry Pi 1, 2, 3 and 5. So over here we can select this one, and this is going to be the Raspberry Pi 4 tray. Rename that one to Raspberry Pi 5 tray, like so. So let's turn off that construction geometry. We've now created, in pretty much 2 operations, an entirely new body. We can right click on these and we can save these as mesh. So if we do save as mesh, this save as mesh allows you to export as an STL file, so you can 3D print it. You can see that STL binary. Click OK, and then you can say that that's the Raspberry Pi 5 tray. Save that. Then go to the other one, save as mesh. Click OK, and then Raspberry Pi 4 tray. Let's save that one. So we've now created 2 STL files, one for Raspberry Pi 4s and one for Raspberry Pis 1, 3 and 5s, or 1, 2, 3 and 5s, all in one operation. So let's save that. OK. It might be that when you're bringing this model into your assembly model, you don't want to have these individual ones. You can actually switch that off if you found that more useful. But there we go. We can also switch back on the Raspberry Pi just to see that that is fitting nicely into all the holes, which it does. So the last thing we need to do is we need to design the top panel. So I'm just going to scroll to that on my list of instructions, and then we can have a go at creating that top panel. So let's do a new file, new design, new sketch on the bottom plane, and this is going to be a nice rectangle. So R for rectangle, center rectangle, click on that, drag it out, D for dimension, and the top dimension is going to be 282.25. The left or right dimension is going to be 200, like so. So that's the entire length of our enclosure. Now I do have some nice chamfered corners on this, so we can click a line and click another line on there. We can click on D for dimension between those 2 lines, and I want this to be 135, so a 45-degree angle. And we can also set the distance between that point and the edge to be 11 millimeters, like so. So let's do that over here. We can actually use the chamfer tool if you wanted instead. So the chamfer does the same thing, so we want that to be equal distance chamfer between there and there, and we can just say that's going to be 11, I think that's right. Yep. So let's do that same operation. That was nice and neat. So modify chamfer, equal distance between there and there, 11, and finally let's do that one more time over here. So that's going to be 11 as well. So you can see up there we've got a kind of tiny piece of geometry that's still its own thing, and I don't like that. I think that creates for a messy extrude later on. So I'm going to go and modify. I'm going to do break. I'm going to break that line there and break that line there, and I can now make that top line, just that tiny section of it, to be construction geometry like so. There we go. So that's the first thing we need to do. We can click on finish sketch. We can extrude this one up by, I think, is it 2 millimeters is what I'm using for my basswood. Let's do A for appearance and drop that pine on there as well, just so we can see that it's wood. And what we need to do now is add the holes for the handle. So let's go for, on this create sketch, on the top sketch we want to create a line between that very top point corner there and that very bottom corner. Do the same over here. These need to be construction geometry, so X to make them so that they're not interfering with that. And then what we then need to do is create 2 circles. So on that line, just find a point and do some circles. These circles, of course, are going to be the M6 size. So M6 equals 6 millimeters. We can save that got a couple of the ones. M6. The distance between these is 120. And these need to be centered on that origin point as well, so we can bring out that, and that's going to be 120 divided by 2, which is 60. You can see they've now turned black, so that means that we've now got, again, we can turn off that body if that's interfering with seeing the nice clean geometry there. I always like to move these around so I can see what's going on as well. Just like that. Okay, we need to do the same on the other side. We could mirror this, but for the speed of it, it's dead quick. We just need to find that line there. Let's just do 2 circles, D for dimension, M6, M6. Now we don't need to do the other piece there. We can simply just use the horizontal and vertical constraint, click on that center point, and then click on the center point of the other one, and they'll be both locked into place horizontally. So we've now created the holes for our sketch. So we can now click on finish. We can now bring that body back, do E for extrude, find that hole, that hole, that hole, and that hole, and then just push that arrow down so it cuts into the geometry. Change that dimension so that it's all the distance is all. Click OK, and you can now see that we've got the holes for the handles. And then finally, I like to have this nice kind of diagonal pattern on the top. So I'm going to show you how to create that. It's another nice simple sketch, but really effective. I'm going to click on the create a new sketch on the top here, and I'm going to create another piece of geometry. So this is going to be a line that from top to bottom. Line from top to bottom, and then a line from left to right. I'm just going to make these horizontal and vertical using the horizontal and vertical constraint tool, and I'm also going to make them construction lines just by selecting them and pressing X again. So this needs to be from the left edge to that line there is going to be 20, and the same with the top and bottom one there, that's also going to be 20. This left one, or the right one, is also going to be 20 from the other edge. Okay, it's going to position the camera a little bit like that. So next I want a line that goes from there to the top one. I want this to be 45 degrees, so I'm going to use the I'm going to turn off the body so we can see the sketch again. I'm going to use the D for dimension tool between that line and the line we just created, type in 45 degrees so we get a nice 45 degree, and we want this line to be 50 millimeters long, so I'm just going to drag that down there, type in 50. I'm also going to make this one a construction line because we're going to build some geometry around this, so that's going to be a construction line as well. So what I want to do next then is create 2 circles at either end, like so. These circles are going to be, I think, 5 millimeters in width, so let's do, drag that up, make that 5 in diameter, 5 in diameter. We want these to touch the top and the left, so if I click on this tangent tool, I can click on the edge of our circle on the top and it'll lock that into place. Click on that edge of that circle, click on the left one, that will also lock that into place. And then what we can then do is just do 2 lines. Let's just do 2 lines like so, and we want these to be parallel, so we can click on the parallel constraint, click on that line there, that's also going to be parallel to that line there, and then we want this to be tangent to that circle as well. So if I click on that line and tangent, these are now locked into place. Now if you really want to be fussy, you can just leave them extruding beyond the boundaries of that circle, but if you want to be really fussy, you can get that end of that line, and if you move it, you'll find that it becomes like an X. If I do that, you'll see that it'll lock into place, and then after you've locked into place, if you try and move it, it won't move anymore. It means it's found that tangent. You can see there a little blue X appears over it as you're doing this. Let's just do that on this one here, like so. And then let's do the same on this one here. There we go. So now, if that's, there we go, that just needed locking into place. So we've now got some geometry. Now the fact that that's not showing blue, just maybe wonder whether that hadn't quite caught there. I also like to do that break thing where we do modify, break, and click on the bits inside our slot. We can now make those construction lines so that we've got a nice single piece of geometry that we can extrude through. Right, let's click on finish. Let's bring that body back. Let's zoom in, and we should hopefully be able to extrude this down now. It looks like I've not quite done that right on that sketch there, so let's just bring that back. I think the very bottom of that circle is construction line, so let's just X that to make that complete. We should now be able to select this. If I do E for extrude, we can now extrude that slot down. Again, let's use the distance to all. Click OK. And we've now got a nice diagonal slot. We want to now use the rectangular tool to replicate that across. So this is the fun bit. So we want, let me just use the rectangular pattern tool. This is under the create pattern and rectangular pattern. We want to select feature. So let's go to feature, and that's the extrude thing that we've just done. And then for the axes, we want 2 axes. We want that to be kind of left and right. So let me just find that. If I just click on that one there, you can see we can now drag that out and drag that down as well. So we want to have 11 of these going in this direction. So 11 of those, and we want them to be, I think, 20 millimeters apart. So over here, if I just move out this so you can see what's going on, we can set this to either extent or spacing. I think if I set it to spacing and do it as 20 millimeters between them, that looks correct. And then similar on this one here, we can just drag this down now so that it looks about right. So I think 60, if I type in, that looks about right. Click OK. And you can see there we've got this nice kind of pattern where there's some ventilation for our Raspberry Pis to vent their heat. So let's disable the sketches, save this one as top panel, call it live top panel, like so. And if we go back to that model that we created last week, which was, if I just X out of that, live assembly is what we created last week. Last week, but one, I think it was 2 weeks ago. So I did cheat by bringing in that top panel just so that we could slot the handles into place. But we can now use the one that we've just created for that. And then if we bring in that cluster panel, if I right click and find our live cluster panel, I think that's the one there. Let's do insert into current design. That should then appear. We can close out this now, and what we can do is zoom in on, I'm going to rotate it around a little bit so that we can actually find a hole to lock this in place. Click OK on that. Now you can use the joint tool to find that hole just there, and that's going to join to that hole, I think. Is it that one there, or is it that one there? I think it's that very top one. There we go. Use the flip tool to make sure that's correct, and then we just need to rotate that round minus 180 degrees. Okay, that is how we can then slot our Raspberry Pi trays into place. So we can bring in that tray that we just created. So the live tray, let's find where that's gone. Pi tray. Did I not save that Pi tray? Let's just go for save, click OK. Let's call live Pi tray version 2. I think I might have actually saved that in the wrong place. I think it's actually in Kev's robots. So I'm just going to move that into the right folder. Yep, there it is. If I right click that and click on move, we can then move that into the mini rack folder, so we can find it a bit easier. If I now go back to mini rack, it should now be there. It is. Click on into the current design, into the live assembly. Now interestingly, watch what happens when we do this. It's going to bring in both of those bodies, and that's not really what we want, to be fair. So if I just close this out, we can, if we want to, go into the individual bodies and switch off the Pi 4 tray if we wanted to get rid of that one, just by disabling it on there. So if I click OK, we've just got the Pi 5, and we can move this around. We can click on the joint tool, find that top hole there, make that top hole join to that one there. We want to flip that round and then rotate it just so it's 0 degrees, like so. Oops. Now the reason that flipped over there is because we haven't got that other one locked into place properly. So if I just jump back here, and let's just make that one, which is the Pi cluster panel. If I right click that, you can ground that to parent, and that will lock that into place. But you'd have to make sure every component that joins to is also locked into place, and it's because these components over here, although we mirrored them, we didn't actually join them together, so they're all sort of floating about. That's why that happens. We can get around that by actually selecting all those, selecting all these pieces. Let's just do that so that we've got all the pieces selected, and then we can do assemble rigid group. That's going to lock all the pieces into place, so we won't have that weird thing happening when we then try and join that Pi there. There we go. So that's how we can model that. We can even switch back on the Raspberry Pi that's in it, just to sort of show it in place, because we included that in that model as well. And that kind of proves that this works. So there's the version that I laser cut before. I printed out two different types of Pi trays. This is the Pi. This is the Pi 3, Pi 1, and this is the Pi 5. So these would sit like so inside. And I've got a whole bunch of, let me just grab these. I bought these from Amazon. It's a pack of about 50 M6 nuts and screws. It even has these little washers as well. If you open this up, you essentially just get a couple of bags of nuts and washers and screws. So if I just grab two out of each of these, just grab these, we can screw that into place. It's really satisfying when you model things and they really do fit, because we've got some good dimensions going on there with the help of the Robot Maker's Almanac. Right, so let's try and do this like so. That goes in there. We put the nut on the back. Put it into place. I'm just going to do it finger tight for now. And then the same with the bottom one. And there we go. They're a little bit fiddly to do these, I've found. Always fiddly when you're doing this live on camera. There you go, spin that round, and I've got a screwdriver. I had a screwdriver. Where's my screwdriver disappeared to? There it is. We can just screw these into place just by holding the nut. Now you can do this in place when this is actually attached to the chassis. You can just put your hand in the side and hold these in place. So you can see there that the Ethernet connectors are kind of reversed in order on the Pis 4, and this is a Raspberry Pi 1 that's just put in there. You can also tell because of the colour. That's the Raspberry Pi 4 with its USB 3, and the original Raspberry Pi didn't have a USB 3, there's a USB 2 on there, and there is a bit of a gap between them. That gap's fine, it helps with the airflow, and we can simply just now mount this using these screws at the side. We just need one at the top, one at the bottom, into the panel, and then provide some power. So you can see that there's enough space to be able to sort of put power connectors in. It would be that way around, so the power connectors are there and there. Plenty of room to do that when it's actually in the cluster. So I have gone ahead and bought some extra power supplies. These are for the Raspberry Pi 5s I'm going to be putting in there. So one of them is a white one. You can't see the white one on there because the studio lights are so sort of bright. There you go. And then there's the black one as well. So both the same, 27 watt. I've also got a few extra bits and pieces for this. So one of the Pis didn't have any storage, so I bought a SSD kit. This is the 512 gig version, the official Raspberry Pi, and I've also got the cooler, the active cooler that can go on there as well. So I'm very interested in creating a version of this for the Raspberry Pi 2W, so that can sit in there. It wouldn't have any Ethernet connectors in there. We could probably buy some USB Ethernet connectors, but we might be able to connect possibly using Wi-Fi, though that might get quite noisy RF wise. I've also got these two compute modules, but they would need some kind of board to go in there. There's the new Raspberry Pi 5 one, and there's the original Raspberry Pi 4. So yes, that's the next steps on there. So let me just see if there's anything else we wanted to cover off on there. I think that's everything that I wanted to cover model-wise. Yeah, that looks good. I did talk last time about the 2U components. If I just bring this one back up, I'm going to find the 2U that I created on the live stream, and then also the one that's the kind of official one. So this is the one that we created on the live stream. You can see in here there's no kind of ribs between each of the sections, just to give it a bit of extra strength. So if I find the one that I've created, which is the official one, and this is what's covered off I think in the tutorial as well. If I just change the colour of this so you can actually see it a little bit better, let's use that colour there. You can see we've got these 4 ribs. So what I did on here, if I go back to here, I created a sketch, and let's just go to that sketch and edit that. So I think it's that one there, sketch number 6. Let's edit that. You can see that the dimensions that we've got on there, they seem a bit arbitrary. So the first one is 14, and then it's the same 15.875, which is the pitch we have between them normally. 14.5, 14.5, 15.875, and then 14.25 on the very bottom one. If we just create some little rectangles on there so that we can see when we go in here, we can then use that line to align a offset plane from the very top. So if we do an offset plane, we bring it down to be, I can actually show you that working. We can bring that down so that it's actually level with that line there, like that. You can actually click on that point and it will go to that point as well if you wish. So if you clicked on that point there, for example, it would click down there. So you can use those points in your sketch to get all the different planes that you need. So you can see that I've created a whole bunch of different planes there, one for each of those different sort of levels. And then I created a new sketch on the top, which was the rib profile. So the rib profile I think on this one is on the bottom, which is there. So you can see we created that rib profile. Let's just bring that one up. So that's essentially 15 from that point to the origin, 45 degrees, and then wherever it lands on there. That's what the rib profile looks like. And then we just do an extrude operation from that rib profile, and then we want to start that from an object, and the object is each of these different planes that we've created. We want them to be 3 millimeters. I think it's possibly 2 millimeters actually, yep. And we want them to be symmetrical, and we want them to be the whole length, like so. And if we do that at each of these different levels, we will end up with a model that looks like this. Let's just turn off those sketches and those construction planes. You don't need one in that middle one there, you just need one between each of the groups of 3 holes, which form one U. And that will give it a lot of extra rigidity to the model so that it doesn't easily flex and snap under any kind of twisting force. So it just gives it a bit of extra rigidity. I print these as well so that that face there is actually on the build plate. So you're kind of printing it like that. So it prints straight up, prints the rib pieces, and you just have a bit of wasted material on there as a support, but that's pretty much it. So that's the bit that we missed out from last week. Just wanted to make sure we cover that off. Okay, back to our slides. Let's get over to this view here. So yes, if you want to get yourself a Robot Maker's Almanac, this is why I created this, so that you've got really quick access to the dimensions that you need, and you can have that to hand. Again, page 27 for those Raspberry Pi 5 dimensions. You can have that to hand while you're building a model. You don't need to have that on a separate screen. It's just so much easier when you've got it in black and white on a book that you can have with you. So Robot Maker's Almanac, grab one of these on the kesrobots.com store if you've not got one already. You can also get yourself one of the 3 PCBs that are currently on sale. So we've got the Gamepad 2. They've been flying off the shelves. We've got the Pico Tamachibi, which is that virtual pet, and we also have this Servo Helper one as well. So definitely check those out. And if you want to get yourself a Maker Notes book, we have these in the packs of 3, all different colours, and these are essentially just blank notebooks. They have tiny little dots on them. I don't know if you can see this if I zoom in on them. I think the studio lights are too bright to show you this, but they've essentially got like tiny little dots on them. I wonder if I can show it on there actually. Yeah, you can just about see there, tiny little dots, and that allows you to create circuit sketches. So you've got like nice little boxes, but subtle enough that it doesn't get in the way if you just want to freehand something. So you can get those in packs of 3 as well. So definitely check them out on kesrobots.com. And if you're not on our Discord channel, definitely head over to kesrobots.com/discord and get yourself a sign-up link. It's completely free, and there's a really great community of people who can help you solve any kind of problems that you have with code, and also you can share pictures of projects you're working on as well. There's some really great projects on there. If you want to follow me on the social media, I'm on all the social platforms. So on Threads, I'm at Kev McAleer at threads.net. On TikTok, I'm at Kev McAleer 6. On Instagram, I'm at Kev McAleer. On X, I'm at Kev's Mac. On Mastodon, I'm at Kev's Mac at mastodon.social. And I'm on Blue Sky at kevsmac.bsky.social as well. So definitely follow me on there. Say hi if you're following me, and we can follow each other on there as well. And if you want to join me and get your name in the credits, you can do that by doing a number of different things, but the easiest way is to head over to kesrobots.com/coffee, and you'll find all the instructions there to get your names in the end credits. So let's do that now for the people who have already followed me and supported me. So over here we have on the coffee side, I think 3 weeks ago we had somebody buy me a coffee. Nobody else has bought me a coffee since then, so you know my coffee cup has just been bone dry. So if you've enjoyed this show, you know what to do. Member wise, we have Silicon Fiber, we've got Marie TKD, we've got Andrew, we've got Shemi, Jeff, we have DN Corty, Marlene and Tom. And on the YouTube membership side, we've got Bert, we've got Dale from Hybrid Robotics, we've got Marie, Michael, we've got Stephen. I always say Stephen, it's because we have a Stephen Cross later on. We've got Steve Phillips, we have Ford, we've got Bello, Orksrad39 at Littleback, we've got Paul, Johnny, Stephen Cross, John Paul, Jolly, Alistair Ware, who I met yesterday at the Cambridge Cam Jam. Really great to meet you there, Alistair. See you face to face. We've got Cassie, we have Tinkering Rocks, Johnny, and of course we have Tom. So thank you to all the people who've supported the show. It means so much to me that you do this, and it means I can continue building amazing projects like this one. And at this point in the video, we've got the little spinny logo thing, which tells me that YouTube will be suggesting over here a video for you to watch next from the backlog of over 400 videos that are now on the channel. So definitely check that video out and let me know what you think about that one. And this is the point in the video. I'll say if you're watching this on replay, thank you so much for watching, and I shall see you next time.